This is the second part of this lecture on strategic financial contracting. In the first part, we studied the model by Bolton and Schorfstein to understand how firms that were competing in product markets could use financial contracting to avoid predation by a financially stronger rival. And so that explained why firms might enter into long-term funding arrangements with their bank. So such funding arrangements would deter predation and making it ineffective in such a way that it will not happen in the first place. Now we're going to focus on another aspect of strategic financial contracting, and this is going to be the choice of leverage by the firm. The choice of the capital structure, the choice between debt and equity. And in particular, we're going to study how leverage is going to have a strategic effect on a firm's competitor and therefore on the competition that a firm is going to face. And so this is a paper by Brander and Lewis in the AR. All right, so to do that, we're going to rely on the standard model of Cournot competition. So as you know, there's two standard models of competition between firms. The first one is Bertrand competition. That's when each firm chooses the price at which it will sell its products. The second one is Cournot competition. With Cournot competition, firms choose the quantity or the output that they will sell on markets. And the price will be affected by the quantities that firms choose to produce. Okay, so more specifically, so if we look at the firm's profit, firm I's profit. Firm I's profit is denoted by pi I, and it's equal to the quantities or output QI produced by the firm multiplied by this term. And so this term is really the price, the market price at which the firm will be able to sell its output. And as you can see, the market price is a function of three components. The first one, so this is a random variable theta. So this is a demand shock, or more generally, any shock that will affect prices. So you can think about it as a demand shock, the demand from consumers for the firm's products. But then the price is also affected by quantities produced by the firms, and not just by firm I, but also by its rival firm J. So already you can see here that firms exert a negative externality on each other, because if they raise their output, they're going to drive down the price at which all the other firms will be able to sell their output. Okay, and the last component of a firm's profits is simply the investment cost. They must invest at first to be in business and to be able to produce output. So what is the uncertainty that firms face? Well, first of all, there's the quantity produced by their rival. This will be determined in a Nash equilibrium. The second source of uncertainty is the realization of this random variable theta that they do not know at the time of choosing their output. They only know that theta follows a uniform distribution and is distributed on this support with a cumulative distribution function h and with a capital H and with a density h. Firms do not know the realization of theta at the time when they choose their output. They're going to take expectations over all possible realizations of theta. Some notation, so total output, capital Q, is equal to the sum of firms' outputs. And here there's only going to be two firms. So all this is very standard. It's a model of Cournot competition with some uncertainty about the price due to this random variable, this demand shock theta. Okay, so we're going to complement this model with a leverage decision. And we're going to consider firm I. And firm I is going to be able to raise some debt. It's going to be able to raise this amount of debt with a reimbursement DI. I'll use a slightly different notation, which is equal to the amount raised, DI, capitalized at the interest rate RI, where this interest rate is such that lenders break even. So we're going to have competitive lenders that make 0 expected profits, and so these lenders must break even. So what is the payoff of a debt contract from the lender's perspective? So we know that it's equal to the minimum between what the firm will be able to produce. So this is the output of the firm multiplied by the price at which the firm will be able to sell its output. So the minimum between this and the contractual payoff of the debt contract, which is equal to that. Okay, what is the timeline? It's pretty simple. So at first there'll be an investment. So that's when you choose to invest this amount. And contracting stage. So contracting stage is when you raise funding from investors, when the interest rate on debt is going to be determined. And firm I is going to move first, followed by its rival. And then at the competition stage, when firms choose their output, everything is going to be simultaneous, which is very standard with core competition. Okay, so now let's take the perspective of the economic agent who is actually making decision in firm I, and this is firm I's shareholder. And of course, here, the perspective of the shareholder of firm I is going to differ from the perspective of a hypothetical unleveraged shareholder. And this is because firm I has taken on some debt and the shareholder is protected by limited liability. So that's going to have an effect on this shareholder's optimal decisions. So what is the payoff of the shareholder? So the payoff that the shareholder will receive, it's equal to the output produced by the firm, QI, multiplied by the price at which it will sell its products, minus what the shareholder must reimburse to the lenders first. This is a contractual debt repayment. And because the shareholder is protected by limited liability, it gets the maximum between this and 0. In other words, he gets this if this is positive, otherwise the shareholder just gets 0. And here we take expectations. We take expectations over all possible realizations of theta, which is not known when you choose output. And you're going to maximize this objective function by choosing output, QI. Okay, so now I'm just going to rewrite this expression by taking the expectation over all possible values of theta. And so I take the expectation. So this is an integral with the PDF of theta right here. And because this is a uniform distribution, this PDF here is going to be a constant. Okay, so just some notations. We know that this is equal to DI. We know that this is total output produced. Okay, so this is quite straightforward. But now what I'm going to do is I'm going to try to determine for which values of theta the max here is going to be equal to this term and when it is going to be equal to 0. So the first thing to notice is that this term here is increasing in theta. So what's going to happen is that the max is going to be equal to this term for all values of theta greater than a threshold, and it's going to be equal to 0 for all values of theta less than this threshold. So how do we determine this threshold? Well, this threshold is going to be such that this term here is equal to 0. Okay, so where is this term equal to 0? So in other words, when is that the case? Well, we just solve this equation for theta, and using this notation, as well as this notation, we find that this equation is equal to 0 for theta equal to this. Okay. So now we know that when theta is less than this, the payoff to the shareholder will be 0. And when theta is greater than this, which you can find also there, the payoff to the shareholder will be equal to this term, which you can find also right here. Here so far, we did not optimize with respect to QI. We just rewrote the objective function, taking into account the level of debt of the firm. So now we're going to optimize with respect to QI. The optimum is going to be given by the first order condition to the maximization problem. We do not actually have to differentiate with respect to this lower bound of integration. And why is that? When theta is equal to this lower bound of integration, we know that this expression under the integral sign will be equal to 0. And this is by construction. Okay, so we only really need to differentiate under the integral sign with respect to QI. Okay, so you differentiate this with respect to QI, and this is equal to that. I call that the marginal revenues because this is the marginal change in the shareholders' profits when you change the quantity produced, taking into account the effect of the quantity produced on the market price. And so the first order condition is that the first derivative of this expression with respect to QI is equal to 0. And this is what you have right here. And it's interesting to compare this to what would be the optimum with 0 debt for an unleveraged firm. Well, you just set DI equal to 0, and you get this expression instead. Okay, so now how can we rewrite this? And we're trying to determine the optimal level of output, QI, that the firm is going to produce. So we can split the integral into 2 different terms. One that will incorporate theta, which is the relevant random variable here, and the other one that will be independent of theta. And so because this is independent of theta, we can take that out of the integral sign. We are left with the integral of a density, but then we can rewrite that using the cumulative distribution function at the bounds of the integral. Okay, so we're going to get this. All right, so now that we have this equation, we have QI here. So we're going to isolate QI on the other side of the equation. And we find that QI is equal to this. Actually, what I did here is that I replaced H of theta upper bar by 1, because theta upper bar is, of course, the upper bound of the support. What is this ratio? Well, this is simply the conditional expectation of theta, and conditional on theta being greater than this amount that you can find here and there. Okay, and then you have minus QJ. So the firm I still takes into account the quantities QJ produced by its rival. But so the interesting term here for our purposes is really this one. Because as you can see, so this is the expectation of theta, conditional on theta being greater than this threshold. But of course, then this expectation will be increasing in this threshold, meaning that when you increase the level of debt, and so you're increasing this threshold, the conditional expectation is going to increase. And so for a given level of QJ, this is going to increase QI. This is going to increase the optimal level of output chosen by firm I. Again, we can do the same without debt. So when the debt repayment will be equal to 0. And we find that it's equal to this, which of course, given QJ, will be lower than this term. So how can we explain that? Here, this shows that with a positive debt repayment, the level of output you will produce for any given QJ will be larger than when the debt repayment is 0. So higher level of leverage means that you will produce more output. So why is that? Well, this is because we take the perspective not of all investors in the firm, so shareholders and lenders, but we just take the perspective of a shareholder. He is the economic agent making the decision. He is the one choosing the firm's output. But from the perspective of the shareholder, he's not concerned about what's happening when theta is low. Why is that? Because in this case, his payoff will be equal to 0 anyway. Right? He's protected by limited liability. The objective function of the shareholder really takes the form of an option. Now your payoff is 0 as long as theta is low, and then it's going to be increasing in theta when theta is higher. And we know that the payoff of an option is increasing in the variance of an option. But what is the relevant variance here? Well, this is the variance of the firm's revenues. Now, the payoff of a shareholder is an option in firm total revenues. Total revenues, I mean that this is the level of output produced times the price at which you will sell this output. Now, what is the variance of the firm's revenues? Well, the only random variable here is theta, and so this is equal to this. And as you can see, as you increase output, you increase the variance of the firm's revenues. Another way to see that is that if you're going to increase output, you're going to increase your losses when theta is low. So when theta is low and you have a higher output, you're going to make greater losses. But it's also going to increase your profits when theta is high. So to conclude, having leverage and having higher leverage is going to commit a firm to be more aggressive in product market competition by producing larger quantities. So why does that matter? Because now we're going to take the perspective of the other firm. And remember, this is strategic financial contracting. So we're considering the effect of financing decisions on the decisions of other economic agents. And so in this case, other firms that we are competing with. So firm J is going to anticipate high output QI from firm I. And so it's going to expect a low profitability. And remember that for any firm, profits are equal to this. So if we take the perspective of firm J, if the other firm increases its output, it's going to drive down the price. And so it's going to drive down the profits of firm J. But then if output is low, the firm may not even want to enter the market in the first place, right? It may not want to incur the investment cost. Why is that? Well, let's look again at the objective function. If expected profits, given that the other firm is going to produce a large amount, so given that the market price will be quite low, if expected profits are quite low, then they will not be sufficiently large to offset the investment cost I. In this case, the firm is going to make losses in expectation, and it's not going to enter the market in the first place. And more generally, we know that outputs are strategic substitutes with corner competition, meaning that when you expect another firm to increase its output, you have an incentive to decrease your own output. And this is your best response. And so in this case, so having high leverage, and we know that high leverage is going to increase the level of output, is going to result in the optimal decision by the other firm to reduce its production. And when QI is larger, the optimal level of QJ is going to be lower. You can take the first order condition. And so the idea here is that firms do not choose their capital structure in a vacuum. They're going to consider the effect of these choices on their competition in product markets. And so this is a strategic effect of a financial structure decision that is going to commit a firm to producing high output. In turn, this is going to deter competition. It may even deter potential entrants from actually entering a market.